So it's time for a big question, and one which also might relate to some people watching on an individual level. The big question is, where is the future of science? And in this, I don't just mean where is science heading, but also which fields of science might you as an individual be able to actually make a noticeable difference. Before we get into the meanings for individuals, let's try to tackle the part of the big question. Science itself doesn't actually have a direction. The quest in science is for new ideas and new understanding, or to question or clarify older ideas and understandings. This can mean that while individuals' projects can be focused on a particular objective, science as a large umbrella term isn't heading for any particular long-term objective. It doesn't mean that there aren't groups out there influencing where the investments in science is going. Companies and governments certainly do have some very focused goals on what they are hoping science can actually do for them, but some of this in turn is also then influenced by public opinion and actual demand for things. So science is like chemistry and biochemistry continually innovating, not just in the form of new medicines and materials, but also in ways of developing these products, also making them cheaper and quicker to produce. Now, those specialising in computers currently focusing on aspects of quantum technology to develop a new generation of faster and more powerful computers. Each generation is getting faster and faster. But while the demand from industry is high for people in these areas, so is actually also the supply of new people into the various jobs. It's difficult for an individual to make much of an impact. So can be said for other high-profile areas like astronomy, cosmology, particle physics, where there are relatively few positions available and lots of highly qualified people trying to get into those very few positions. Some TV shows and similar media also influence the supply and demand of various scientists, as well as the general direction of some fields. So a few decades ago, there weren't any forensic entomologists or forensic psychologists, and now, while there are very many of them, there are many more people actually trying to enter into these fields. Same thing also applies to the number of people who want to study animal behaviour in the wild, so prepared to spend months or years studying out gorillas or elephants or whatever in their natural habitat. So if these areas are full of high qualified individuals competing with each other, there are relatively few positions available. Where can somebody potentially make a real difference? Well, there is an area of science which is probably one of the very earliest forms of science, which is now largely overlooked, in part because many people don't even consider it to be a science at all. But modern scientific instruments, the potential in this field is now considerable. The field of study I'm thinking about is biophysics, or studying plant and animal biology, focusing on physics of how they move and operate, applying that knowledge gained studying them to the human world. The science of biophysics basically led to human gliders and then heavier air flight, and many other everyday items that we now take for granted going back thousands of years, including things like innovations in tunnelling by observing shipworm behaviour. But back to the study of flight, some elements like flapping wings proved to be a developmental dead end. Sent wind tunnels and then later computer modelling led to a more focused and targeted approach to flying. And quietly the area of biophysics as being a source of innovation was largely dropped. Biophysics, though, has made a comeback as people are looking at the natural world to provide natural, novel solutions to problems on a human scale. This can be on the large scale with studying animals and heating and cooling mechanisms. For instance, antelopes in the Sahara Desert can change the colour of their coats. In the scorching heat of the summer, their coats are white, reflect a lot of the heat back to their environment. These coats then turn brown in the other seasons to match the colour of their environment. This aspect of colour changing can be used in buildings to change the reflective index of the structure, keep it cooler on the hottest days. Same general principle also occurs in bearded dragons, but rather than it being a seasonal mechanism, here the bearded dragon can alter the colour of its skin in seconds by changing where melanin is stored in the skin, much like how cuttlefish can camouflage their skin to match their surroundings. But in the case of the bearded dragon, it's making a change in relation to temperature. In theory, this dispersal of colour could be used to alter the roofs in response to local weather conditions. Scientists are also studying mechanical methods for plants in violent seed dispersal or the power of a mantis shrimp club, along with bioluminescence and construction from beaver dams to termite mounds. All these items fit in with the traditional methods used in biophysics, but some of the future for exploration is going to probably focus more on the microscopic level. Whether using optical microscopes or electron microscopes, these devices are revealing the inner workings of biological organisms which have never been fully studied before. In dealing with the very small parts of living creatures, these individual elements have evolved to be at near maximum efficiency, so potentially could give us new insights when they're scaled up for human use. The real challenge in biophysics isn't actually going to be picking out the special features of these biological samples. Instead, the task is going to be figuring out how to actually apply these novel figures and get them to work on a human scale, and work out what materials could possibly be used to actually make them function well. This application of the knowledge is going to be what separates biophysics from the other innovative fields of science. The application of the new knowledge will require people who can think in innovative and imaginative ways rather than being purely those with the top qualifications from the big universities with the highest reputations in the respective field. So it'll open up the opportunities for more people to make a major difference in those fields which I mentioned at the start. These individuals are likely to require a wider range of knowledge than the traditional experts. The people, of course, will need a good understanding of biology and also possibly chemistry and engineering and some other related fields, actually enable them to apply those principles to finding out real-world solutions.